Hello, welcome to the video. I'm going to attempt to explain Arc and Mutex. This is going to utilize threads, Arc and Mutex, to concurrently modify shared data. We'll create a struct and we'll modify the data in it. Each thread appends unique updates, demonstrating safe, synchronized access to shared resources in a multi-threaded environment. So we're going to use standard sync, Arc, Mutex. We'll also use standard thread. So the first thing we want to do is we'll create a struct called shared data. The content field will hold a string instance, and the data inside that string, the actual text content, will be stored on the heap. So inside main, we'll have some shared data wrapped in an arc and a mutex. So the shared data is effectively an instance of the struct we just saw. The initial content will be initial shared content. That's what you would see if you did nothing else after this. So shared data is effectively string wrapped in a mutex, wrapped in an arc. Three separate arc references are created by cloning the original arc containing the mutex wrapped shared data. So shared data that we just looked at, that is wrapped in a mutex, wrapped in an arc, and then we clone that arc. So we're making clones of the arc pointer. The arc clone method increases the reference count of the underlying shared data, ensuring that multiple threads can safely share ownership of the same data. They can share it, but they can only modify it one at a time, as we'll find out. So how could we print the reference count if we wanted to know that? This is the function. So strong count, you'll come across strong count, and each time you use arc clone, it increments the strong count. Not strictly necessary, but useful to know. Okay, so what we want to do is create some threads. So probably familiar with creating threads if you've done any threads tutorials. This line, the first line, spawns a new thread using the thread spawn function. The move keyword is used to transfer ownership of the captured variables into the closure, allowing them to be moved to the new thread. Without that, you would have problems and you would get an error. You need to move. So carrying on the next line, so inside the closure, we've got let mutable data equal thread1 data. So thread1 data is the arc clone. And then we use here thread1 data is an arc reference to the shared data wrapped in a mutex. The lock method is called on the mutex to acquire a lock. The lock provides the exclusive access to the shared data. The unwrap is used to check for panic in the case a lock can't be acquired due to a potential poisoning scenario. And then on the next line, data.content. So data is our, so with the lock acquired, this line modifies the content of the shared data. It appends the string, so updated by thread one, handle one is dealing with this, and then we'll have a handle two, and we'll have handle three, which have their own messages as well. So since the data is a mutable reference to the shared data, the modification is safe within the confines of the lock. At the end of this, so let handle one equal thread spawn, etc. The implicit drop of the lock happens. The mutex guard returned by the lock method is automatically dropped when it goes out of scope at the end of the closure. This drop operation releases the lock, allowing the other threads to acquire it, and we're going to create thread handle 2 and handle 3, which will create their own threads. So once we've got handle 1, 2, and 3, we'll then wait for them to finish using join. When you use join, you need to use unwrap or handle a potential error. Then at the very end, we'll print the content of the shared data after all of the threads have completed. So we'll print the final state of the shared data. So again, we'll do the data equals the shared data with lock, unwrap again, and then we'll print it. So we'll print the data content, and then we should see this, which is the printed content of the shared data after all threads completed. Final shared content equals initial shared content updated by thread 1, updated by thread 3, updated by thread 2. It's because it's non-deterministic. Sometimes thread 3 could complete before thread 2. If you saw my previous video, you'll see where I worked with the colors, and then you could really visually see how the threads don't complete in sequential order as you might expect. Each thread appends its unique update. The mutex ensures the exclusive access, and it prevents data races and ensuring correct modifications. So without this, you would get data races, and then one thread would modify the value, and then the next thread would go and attempt to modify it, and they could get out of sequence, and you could end up with the wrong result at the end. If you want to read more about this, and as I was going, I did look at ChatGPT and ask it questions. And to be honest, with ChatGPT, I have no shame. I'll ask it the most stupid questions if I feel like it. One of the questions I asked was, why can't Arc clone happen inside the thread? And you don't want it to. It needs to be outside, otherwise you get all kinds of errors, borrow errors. Try it. One other example like this, I created the 3 handles and threads separately, but you could have done that within a for loop, and sometimes you'll see that. I didn't want to do that. I wanted to try and keep it more basic and manually, or not manually, but create the 3 threads in code so you could actually see that there were the 3 threads being created, the 3 Arc clones. So yeah, you have to do the clone outside of each individual thread. If you like this video, subscribe to the channel, and I'll keep making more stuff. Quite enjoy it. It helps me learn stuff because I have to kind of research it, practice, and I have to, well, hopefully know what I'm talking about. I'm sure I don't 100% always know, but yeah, hold my hands up there. But I think the way to improve is to try and explain stuff, even if you explain it to yourself with nobody around. Thanks for watching. Please add comments, suggestions for videos, suggestions on how the code might be improved, or tips. Have you got like any tips on how to do stuff differently or more quicker, or even if you got tips on Vim or NeoVim, I'd be interested to hear. So I'll just demonstrate the code. I forgot to do that one time, and it was yeah, poor show. So I'm just going to run the code, and then you see, oh, thread 3 finished first there, look, then 2, then 1. And then I'll just show you the code as well. That is what we've just seen on the slideshow. It wasn't PowerPoint, by the way, it was Google. But yeah, so those are the imports. We've got our struct. I added derived debug just to help print it. Then inside main, we've got our shared data, which is basically our, let me just turn off the inline hints. There we go. So then we've got our new arc, our new mutex, and then we've got an instance of our struct inside all of that. So it's basically once we've got the content inside the mutex, which is inside the arc, a bit like kind of a, yeah. So thread 1, thread 2, thread 3, we're creating the threads. Each one of those is a clone of the original the shared data. Handle 1, handle 2, handle 3, then we join them, and then we take the lock at the end so that we can work with it, and then we do the final shared content, print the data. In fact, do I need the shared data lock? I think I do. Just while I'm here, let's take that out and see what happens. Yeah, we get the error. Method not because it's complaining about the unwrap. This won't work anyway, but just for lols. Yeah. Unknown. So there we go. You do need the unlock. Take that back out. We do need the lock. So remember, you need the lock at the end if you want to do something with the underlying data. So thanks for watching, and yeah, comment, subscribe, thumbs up, and all that, and I'll catch you in the next video.